Welcome. This is laboratory experiment number 3, Gauss Seidel method using MatLab. This activity will allow the student to implement the Gauss Seidel method using MatLab, Freemat, Mathematica, or similar software. The objective of this experiment would be to construct a function script using MATLAB, demonstrate your understanding in solving systems of linear equations, understand and implement the Gauss Seidel method to find solutions to systems of linear equations using software. Alright, here is the procedure in our experiment. You could pause this video and scan and look at your notes for reference. Okay, so we are now going to do the experiment, and the pseudocode can be found on applied numerical methods with MATLAB for engineers and scientists by Stephen C. Chopra. It's the 3rd edition on page 289. Okay, you could get this copy of the book. You could download this online PDF version of this book. So you could just simply copy and paste this pseudocode and apply it to your MATLAB. Okay, so here is the code. The function Gauss Seidel, which have 4 arguments: A, B, ES, max IT, where A is the coefficient matrix, where B is the right hand side vector, where ES is stop criteria, whose default value is 0.0001%. Okay, where the max IT, or max iterations, is the maximum iterations, and the default value of this is set to 50. Then we are going to get an output as of x, where x is the solution vector. Okay. Now, further in the procedure, we are going to check if the arguments is less than 2. It will going to show an error message that says at least 2 input arguments are required. Okay. The next step would be if arguments are less than 4, okay, then only 3 arguments are provided without max iteration. Then by default, the max IT is going to be at 50%, and for arguments less than 3, okay, the ES, which is the stop criterion, and if not, it will going to say ES is equal to 0.00001%. Now we are going to provide the input A with size mn, where m is the number of rows and n is the number of columns. and we are going to check if m and n will be equal, then the input vector a, and if not, it will going to show an error message that says the matrix must be a square matrix. Okay. Further, we are going to assign matrix A to temporary matrix C. Okay. You can see there are two for loops here. Okay. These two for loops for performing iterative operation with the first element is first element divided by its diagonal element, that is either A11, A22, or A33. After this, we send a iteration back to the iteration counter to 0 again. Then search to move further procedure of the running sum. So in this while loop, where's the while loop? Here. First while loop, it will continuously updating the x value. Now this operation is the running sum operation to update the criteria of a operation. And after its circulation, we are going to increase the value of the iteration counter. Okay. Then if max EA, this on line 38, this condition checks a newly updated value for stop criteria is less than or equal to the previously set value, and the iteration counter is greater than or equal to max IT, or it is set to a default 50 value, and if so, it is going back, and it will print out an output on the screen. So let's check. We are going to run our program. Okay, and then we are going to give our first two arguments. So we are going to make a square matrix. Okay. 2, 3, 1, 2, 3. Okay. We are going to close this. Okay. We now have a square 3 by 3 matrix. Then we are going to set our right hand side vector. Is equal to say our vectors would be where's that equal sign again on this laptop? Sorry about that. Okay, let's say it's 3.2, negative 13, and 15.8. Okay, close. Just the brightness again. Close our argument here. So we now have our the argument, so our right hand side vector. So let's try if our small program works. Gauss Seidel. Okay, it works. So the answer would be our solution vector would be negative 614.2, negative 405, and 480. So this concludes our experiment. See you on the next video. Thank you very much. Questions. Suppose tolerance is set to volt by 0.0001%. How would you modify codes such as the nmax or the maximum iteration to terminate the program and display the result? So if we now have the non-zero values from the first iteration, we can compute approximate error estimates as each new value is computed. At this point, although the error estimate for the first unknown has fallen by 10%, stopping the criterion, the second is not. Hence, we must implement another iteration. At this point, we can terminate the computation because the estimates have fallen below 10%, stopping the criterion. Question 2. So, what could you conclude on this activity? So, we learned how to do the Gauss Seidel method of solving matrices, vectors, and further enhance our knowledge of using our MatLab.